Hello students, it's your NOLA Mathman coming again to do another math adventure with my students here. Looking forward to our new concept that we're doing. Unlike Superman, I cannot leap tall buildings in a single bound. I'm not faster than a speeding bullet like Superman. But in regards to math,
Superman got nothing on me.
At the end of this video, students will be able to solve quadratic functions by the process of completing the square. The concept we're looking at again is quadratic functions. The skill that we're going to learn today is completing the square. So with no further ado, let's get started with our lesson. So again, we're looking at completing the square. This is another way of doing quadratic functions. Before we get into the process of completing the square, we will do a portion of the completing the square process, which is this process of using the square root property to simplify perfect squares. So we're going to do some quadratics that involve that process. It says in the group of problems we're doing, solve each equation by using the square root property, round to the nearest hundredth if necessary. So we're going to start with number 1. X squared minus 8x plus 16 equals 1. Now, this quadratic is a perfect square. In other words, this can be simplified using a binomial square. X minus 4 squared is equal to x squared minus 8x plus 16. So since I know that, I will write x minus 4 squared equals 1. Since it's a perfect square and it has a square, we know to get x minus 4, we will take the inverse of square, which is the square root. And so we will square root both the left side equal sign, we will square root the right side. And so we have the square root of x minus 4 squared, which is x minus 4. The square root of 1 is going to be plus or minus 1. And so now we have two equations, which you'll see in a sec. We got to get rid of negative 4 by adding 4 to both sides. X is equal to 4 plus or minus 1, so that means x is equal to 4 plus 1. X is equal to 4 minus 1, and that will give us two values of x, which are 5 and x equals 3. And so we will solve the first problem by using the square root problem. So we'll do now number 4. We have 4x squared minus 4x plus 1 equals 9. So again, 4x squared minus 4x plus 1 is a perfect square. That will be equal to 2x minus 1 squared, which is the perfect square that if you multiply, you will get 4x squared minus 4x plus 1. So we rewrite it as a perfect square. To get rid of the square, we take the square root of both sides. On the left side, we get 2x minus 1. On the right side, we will get plus or minus the square root of 9, which is 3. So now we break this into two equations. 2x minus 1 equals 3. 2x minus 1 equals negative 3. So on the left side, we will add 1 to both sides to get rid of negative 1. Add 2x is equal to 4. We divide both sides by 2 using the inverse operation of multiplication. X is equal to 2. That's our first solution. And in the second equation, we add 1 to both sides to get rid of negative 1. Negative 3 plus 1 is negative 2. We divide both sides by 2, and x will equal negative 1. And so our two answers will be negative 1, x equals negative 1, and x equals 2. All right. So we've done two problems where we have used the square root property to solve for x. Look like we didn't erase some yellow, that's okay. And now we put x plus x squared plus 4x plus 4 equals 2. X plus 2 squared is equal to x squared plus 4x plus 4. We set that equal to 2. We will take the square root of both sides to get rid of the square on the left side equal sign. We will get x plus 2 equals plus or minus the square root of 2. We will subtract 2 on both sides to get rid of positive 2, inverse operation. and x is equal to negative 2 plus or minus the square root of 2. That should be our answer. Problem do y'all want to do next? We'll see what Mr. Mathman. Okay, the NOLA Mathman does number 8. We got x squared plus 16x plus 64 equals 15. So again, the trinomial there is a perfect square. That is x plus 8 squared. We set that equal to 15. To get rid of the square, we take the square root of both sides like we've been doing. We get x plus 8 equals plus or minus the square root of 15. To get rid of positive 8, we will subtract 8 from both sides. And x will be equal to negative 8 plus or minus the square root of 15. So right now we're setting up the concept of completing the square by learning how to utilize the square root property. Now we're at a point now where we can start solving some problems by completing the square. But before we do that, we have to learn how to get the third term and actually complete the square. Problem reads, find the value of c that makes a trinomial perfect square. Because sometimes you don't have a perfect square trinomial, unlike the problems we just did, and you have to be able to create a perfect square trinomial. So in this section, we will learn how to do that by determining c in such a way that we can create a perfect square. So when we complete the square, we will be using this process of creating c to be able to solve by completing the square. So you'll see when we do a problem with completing the square. So let's get into the process and learn how to solve c. So we'll start by doing number 9, x squared plus 10x plus c. Write the general form of a quadratic above it when you complete the square, which will be x squared plus bx plus b over 2 squared. So I should have wrote that above, but basically, oh, there we go. So this is the general form, x squared plus bx. To add c, that is b over 2 squared. We pull out b. B in this problem will be equal to what? What do you think b is? Well, yeah, if you compare the two x squared plus bx plus c and x squared plus 10x, you will see that b is 10. And so we substitute 10 into the equation. We have 10 over 2 squared. 10 over 2 is 5. 5 squared is 25. And so c in this problem will be 25. So now we're going to do number 11. We have the problem x squared plus 24x plus c. That should pop up in a sec. There we go. So again, we will write that same general formula of x squared plus bx. We know the third term, c, is b over 2 squared, so we write that. We will pull out the b term, and b in this case will be equal to whatever is multiplied by x. So in this case, b is 24. So we substitute 24 in to find c. 24 over 2 squared is going to be c. 24 divided by 2 is 12, so 12 squared is going to be c, and that's equal to 144, since 12 squared is 12 times 12. There we go. So we erase that. Now once you get in the habit of finding c, you will see how useful this will be when we solve the equation by completing the square. So let's try a problem that will get us a c term that's a fraction. So let's try 14. X squared minus x plus c. So again, this time we write the general form above it right away. We will write x squared minus x plus b over 2 squared. We pull out b. B is equal to what, class? It's -1. Yes, you are correct. And we will substitute -1 for b. We will have -1 over 2 squared. -1/2 squared is -1/2 times -1/2, which is equal to 1/4. Because two negatives give you a positive product. And so the answer is 1/4. Very good. So we'll start with 15. x squared minus 13x plus 36 is equal to 0. Now, since this is not a perfect square, we have to eliminate the 36, which you will see here in a second. And so you're gonna subtract. So what I do right now is I put the general form of completing the square, which is x squared plus bx plus b over 2 squared. And that will factor into x plus b over 2 squared. Since 36 is not a perfect square for 13, when b is negative 13, we will subtract 36 from both sides. That will be our first step. Because we want to get the two terms together so we create the third term. So now on the left side, we have the two terms we want. X squared minus 13x. We put b over 2 squared because that will be the form of our third term, which we learned in the last group of problems. Since we added b over 2 squared on the left side, we have to add b over 2 squared to negative 36, which you will see in a second pop up on the screen. So since b is negative 32, b is negative 13, we'll substitute that in for b. And we have negative 13 over 2 squared. So we have to write the same thing on the right side to keep it equal. So we put negative 13 over 2 squared on the right side. So at this point, we will simplify. Negative 13 over 2 can't be reduced. So we're just going to square that. And that will give us a product of, basically it's negative 13 over 2 times negative 13 over 2. And what does that equal? That equals 169 over 4. So we're going to add that on the left side. And we're going to add negative 36. And we're going to add 169 over 4 on the right side to the value of negative 36. Now, once you do that, now you have a perfect square. So now on the left, you can write that as a binomial square. And so that term will be x minus 13 over 2 squared is equal to negative 36 plus 169 over 4. Since we have a fraction 169 over 4, we have to rewrite negative 36 with a denominator of 4. So that's what we're doing right now. So 1 over 4 is equal to negative 36. Well, that's negative 144 over 4. We're going to now add 169 over 4 to that. And that will get us basically 25 over 4. So at this point, we take the square root of both sides to get rid of the square on the left side of equal sign and get x minus 13 halves. So we take the square root of both sides, which I think we don't have enough room, so we're going to have to erase some work first, and then we will be able to do that. So we take the square root of both sides. And when you do that, you will get plus or minus square root of 25 is 5, the square root of 4 is 2, so that will be plus or minus 5 halves. So now we're going to erase so that we can have room to finish our work. So this will take a little while here. So unlike your paper where you have unlimited paper, when you do it on these whiteboards, we have limited space, so we have to erase from time to time to finish our work. So we rewrite what we had left before we erase the bottom of the screen. We have x minus 13 over 2 equals plus or minus 5 halves. Now we will get rid of negative 13 over 2 by adding 13 over 2 to both sides. And we will get a value of x that is equal to 13 over 2 plus or minus 5 halves. We break this into two separate problems, which will be 13 over 2 plus 5 halves and 13 over 2 minus 5 halves, and we will get two values of x. Our first value will be 13 over 2 plus 5 halves, which is 18 over 2, which will equal 9. And the next value, 13 minus 5 is 8 over 2, and 8 over 2 simplifies to 4. And so our two answers will be x equals 9 and x equals 4. So it should pop up again here. There we go. So we like to circle the answers when you finish, just to let your teacher know when you do work that this is your final solution. And so we have solved this quadratic by completing the square. Now, as you know, there are different ways you can get that same answer. You can solve it by graphing, you can factor it, you can complete the square, or you can do quadratic form. So there's a variety of different methods that one can use to solve quadratic functions. So we did number 15. Which one will we do next? Let's go to number 16. We got a problem where we don't have but two terms. So this is actually an ideal way to complete the square because you only have two terms. You can create your third term in this problem very easily by adding b over 2 squared to both sides. So you write your general formula first, which you always want to do when you complete the square. X squared plus bx plus b over 2 squared equals x plus b over 2 squared. So we know b in this problem is equal to 3. We write that down. And now we create our third term. So we will put b over 2 squared, which is 3 over 2 squared. And on the right side, we will put 0 plus 3 over 2 squared. Because what you do on the left side, you must do on the right to keep them equal. So now you will simplify 3 over 2 squared, and we know that will equal what? Well, 3 squared is 9, 2 squared is 4, so that will be 9 over 4. And we on the right, you will get 0 plus 9 over 4, which is equal to 9 over 4. So now we have a perfect square trinomial, so we write it in the form of x plus b over 2 squared. In this problem, that will be x plus 3 half squared. To get rid of the square, we square root both sides. We get x plus 3 halves equals plus or minus the square root of 9 fourths, which is 3 over 2. Now we will subtract 3 halves from both sides to solve for x. And so x will be equal to two things, two equations. We will have negative 3 halves plus 3 halves. And we will have negative 3 halves minus 3 halves, which will pop up in the set. Just when you erase it there, once we erase it, we'll be able to break negative 3 halves plus or minus 3 halves into two equations. So let's get this out the way here. And we'll move our problem up to the top, which you will see in a second. And we will finish. There we go. So we got x equals negative 3 halves plus or minus 3 halves. And rewrite that as two equations. Now we rewrote it, we can erase the bottom. This will give us x equals negative 3 halves plus 3 halves. That's your first equation. And x will be negative 3 halves minus 3 halves. Now, negative 3 halves plus 3 halves is 0, so the first equation is equal to 0. First value of x is 0 over 2, which is 0. That's one solution. And then here, negative 3 halves minus 3 halves is negative 6 over 2, which is equal to negative 3. So your values for x is equal to 0 and negative 3. So you circle it to indicate you're finished with the problem. Very good. So now we've done two of these problems by solving, by completing the square. Now we want to do one where a is not 1. So we'll do 19. 19 states 2x squared plus 7x minus 4 is equal to 0. Now in order to complete this, you see when you do the general equation for completing the square, that there is no term in front of the x squared. So we have to get rid of the 2 before we complete the square. So the first step we will do before we add, well, first thing we want to do is get rid of the -4 by adding 4 to both sides and creating 2 terms. But before we put b over 2 squared next, we will have to get rid of 2. So we divide all 3 terms by 2 to get x squared, which we need. Now when we do that, we'll end up with x squared plus 7 over 2x equals 2. Now in the same vein, we can add the b over 2 squared since we now have x squared. So we add b over 2 squared to both sides while simplifying the problem at the same time. So we're kind of doing 2 steps in one. We set b equal to 7/2, and we're going to substitute that into b over 2 squared. So you'll see that appear in a second. So you have 7 over 2 divided by 2. And on the right side, you have 7 over 2 divided by 2 squared, and we're going to add that to 2. So whatever you do on the left, you got to remember to do the same thing on the right side of the equation. Now, 7 over 2 divided by 2 needs to be rewritten. We're not used to having fractions in a fraction. So what I will do is I will have you rewrite this, and then we will figure out what 7 over 2 divided by 2 is equal once we rewrite it. You'll see that happen there. There we go. And so we know that is equal to 7 over 2 divided by 2. We write it division as a division sign. So now we're going to rewrite it. When we divide fractions, we know we have to multiply by the reciprocal of the second term. So we change it to 7 over 2 times 1/2. We multiply across because we can't factor. 7 times 1 is 7, 2 times 2 is 4, and so we have 7/4. That's what 7 over 2 divided by 2 is equal to. So now we're going to substitute that into the equation on both sides of the equal sign, and we will rewrite x squared plus 7 over 2x plus 7 over 4 squared is equal to 2 plus 7 over 4 squared. So it takes a little time when you have fractions. You have to do a little extra steps to simplify the fraction, but it's worth it once you do. So we need to erase the word so we have room to finish the problem. That's what we're doing right now. And we're going to write our last step at the top of the page, and we're going to finish the work. So we have here x squared plus 7/2 x plus 7/4 is equal to 2. 7 over 4 squared is equal to 2 plus 7 over 4 squared. So now we have to simplify the b over 2 term squared. We have to square 7 over 4 squared. 7 squared is 49. 4 squared is 16. So 7 over 4 squared will be 49 over 16. And you will put that on the left side of the equal sign and the right. So we will rewrite the equation, and it takes a minute to figure it out, I guess. So we have 7/2 x plus 49 over 4. 49 over 16, because 4 squared is 16. Don't make that mistake like I was about to do. And so on the right side, we'll also write 2 plus 49 over 16. So now we can write the left side as a perfect square trinomial in the form of x plus b over 2 squared, which you're about to see. And so that will be x plus 7 over 4 squared. Now on the right side, we must get the least common denominator to be able to add 2 plus 49 over 16. 2 is equal to 32 over 16, so we're going to write that so the denominators are the same. That allows us to simplify the right side equal sign, and that will be equal to 81 over 16. Now we'll take the square root of both sides to get rid of the square. That will give us x plus 7/2 equals plus or minus the square root of 81 over 16, which is 9 over 4. So that's plus or minus 9/4. At this point, we subtract 7/2 from both sides to solve for x. And when we do that, we will get x equals negative 7/2 plus or minus 9/4. We create two equations from that, negative 7/2 plus 9/4, and we will have negative 7/2 minus 9/4. Now again, since the denominators are different, we have to get a least common denominator, which will be 4, and we will put negative 14/4 plus 9/4. That will be the first equation, which is equal to negative 5/4. And in the second equation, we will have negative 7/2 minus 9/4. And again, we will rewrite that as negative 14/4. Negative 14 minus 9 is equal to negative 23/4. That's what you will end up seeing in a second. So that should give us a final. So our answers will be negative 5/4 and negative 23/4, which will pop up in a second here. So we've solved both problems. So we got two solutions for this quadratic function. X equals negative 5/4, x equals negative 23/4. So now we're done with that. This is our last problem on the concept of completing the square. Again, after this video, you should be able to solve quadratic functions by completing the square. Went through a variety of problems. And so now the NOLA Mathman is signing off. Until we meet again for another math adventure, you have a blessed day. Bye-bye.